Okay, looking at a little bit of reasoning behind the definition of the derivative. If I want to find the slope at a point x, it's actually a point x comma f of x. One way to get 2 points that are close together, because remember we've talked about the secant line being an approximation of the actual line, is I go over a horizontal distance h. So if you go over a distance h, you get to x plus h. So this new point on the curve is x plus h, f of x plus h. Yeah, I don't feel like talking. The only simplification that we can do is the x's on the bottom. So everything else is stuck inside something. Okay, so if we have a value to look at, there's a couple of ways we can do it. We can plug in so we're looking at f of x plus h minus f of x all over h as h goes to 0. So I need, in this case, if I'm plugging 3 in at the end, I'm just going to leave x as x, but I do need to see what f of x plus h is. So we've been having this little spiel about the fact that you're not just adding h at the end, you're replacing the x's by x plus h's, all of them. So if there's 2 x's in the original function, there's got to be 2 x plus h's, and then we simplify. Don't forget to FOIL that properly. Okay, and I'm going to distribute the 2, and I think in order to save space, I'm just going to put it down here. So you need to write the word limit as h goes to 0. I won't ding you unless you write it at least, if you write it at least twice. I sometimes forget to write it in the middle also. Let's see, distributing the 2. Now be careful, because all of that is just f of x plus h. So I would suggest, even though it's not necessary, extra parentheses so you can visually distinguish f of x plus h and f of x. Okay, does things cancel? 2x squared with minus 2x squared, and negative x and negative negative x. So that sounds good. And what's left? Okay, so I can cancel an h if I cancel it out of every term. Yeah, if you cancel the h, it leaves a 1. It does not leave a 0. So factor, cancel, plug back in. And the final answer, just plug in 3 at the end. Okay, I can also plug in 3 at the beginning, and you often see this in textbooks. So if I look at f of 3, so we're doing limit definition of the derivative. Limit as h goes to 0 of f of x plus h minus f of x. F of x plus h, f of 3 plus h is this. So and then f of 3 was 15. Don't forget the denominator. Oh, look, the 15s cancel. And I forgot to write the word limit. Oops. Oh, why did I write a minus 11? It doesn't matter. I'm going to get rid of that plus sign. Cancel an h. Plug back in. Oh, look, it's 11. What a surprise. Alternative definition of the derivative. I'll talk about why this might be the alternative definition. Okay, so we do the slope, it's f of x minus f of a over x minus a, and the limit just gets you closer and closer to the approximation you want. All right, so let's take a look at what we got here. We already know f of a, but because it's the same question. All right, so f of x is 2x squared minus x, and f of a was 15, and a was 3. Okay, whoops, limit. Factor the top, 2x and x. I bet one of the factors on the top is x minus 3, sure enough. Yes. You'll get negative 6x and plus 5x is negative x. So factor, cancel. You can only cancel because of the word limit. Oh, look, it's 11. What a surprise. Okay. Eight plus 2 is 10. All right. X approaches a, f of x minus f of a over x minus a I bet this is x plus 2. This is a minus 5. Yes, because you have plus 4 and minus 5. Good. And the word limit. Again, I won't ding you too much because I forget it myself frequently, but do it at least twice per problem. Okay. Tangent line to the same, say, okay, so again, point slope form. What is f of, f of 3. That was 815. Okay, actually, what I'll do is I'll write down the formula here. Okay, so the slope was 11. Okay, point slope form. So just a little note. Okay, and also a note, I want to note that I can't write things. Okay, so for instance, when I look at problem 4, the alternative definition, I got 2x plus 5 when I was doing 3, and I got 2x minus 5 when I was doing -2. It's not the same, you have to recalculate it every time. So the alternative definition is not as useful as the proper original limit as h goes to 0 definition.